as in those of you who may have come later, the slides are available if you want to download them and follow them. I will show that slides thing later on too, just in case people come later. So. So after that 94-degree heat, which I seem to have brought from Phoenix, it's raining outside. So it's kind of pretty auspicious. Okay, we'll get started. Karthik, you're there, right? Okay, great, thanks. Thank you all for coming to this tutorial on the role of large language models in planning. As I basically was saying yesterday, my original idea was that we'll propose a tutorial. Karthik and Matthew and Lynn would make the slides and do the tutorial while I happily walk around in Prague. But things didn't work out that way. So I am actually going to do the tutorial. So the 3 full hours, you get to hear me. Of course, you know, both Karthik and Matthew and Lynn helped. Karthik in particular, he's actually up in Arizona, which is, I believe, 5 o'clock in the morning. And which for me, it's very simple. 5 o'clock in the morning, I'm always awake. But I know that some of you younger people, 5 doesn't exist. So, you know, he actually, you know, is ready to answer any questions that I might need to send it to him. Okay. As I mentioned, the slides are available and you can follow along. And also, since we do have basically there are 2 parts, I guess this is a 2-part tutorial. It's like a full 3 hours. So at 3:30, there's a break. And then until 4, I believe, that's the coffee break. And then from 4 to 5:30. And I have stuff for the entire time. And yet, if you have questions, pressing questions where you're kind of completely lost, please do raise your hand and then we'll see. Oh, it'd be useful to actually be on the same page. Okay. Anyway, so that's what I am going to do, the role of large language models in planning. So the aim of the tutorial is the following. So basically, currently, you know, even though ICAPS proceedings don't talk about it, there's a large amount of research being done, lots of papers being written about planning abilities of large language models. They normally get published in NeurIPS, ICML, and also NLP communities. And then basically the idea was that originally they started looking at, can we just train sequence learning models? Basically, the tabula rasa, that means those sequence learning models are essentially empty. They don't have any pre-training. And you just show them large numbers of plans, and then will they be able to predict the next action in the plan? That's a very reasonable thing. In fact, we have done that kind of a work in ICAPS community, including in my group. I will mention that later. And in fact, there are words when this got done with the newer sequence models, transformers, which are essentially the backbone of LLMs currently. I mean, there are lots and lots of sequence models, right? Recurrence networks, and would also be fine. But the ones if done on transformers was actually being done like 3 years back. Decision transformer is one of these pieces of work that got a lot of publicity. And much more recently, and more recently, most of the work has actually shifted to just trying to use pre-trained models. The models have been trained on the entire web scale corpora of web scale text, and then seeing what if they can do some magical planning because they, as several of you know, and know, basically there is this quote unquote emergent abilities of large language models. They were basically trained to kind of predict the next token in a sequence given the context window, which depends on the model. ChatGPT, which we'll keep repeating, looks at approximately 3,000 previous words to predict the next word. And we'll get to this later. So then, even though that's what they were trained to do, they seem to be doing things, is a very important issue. Doing other things like basically answer questions about various subjects, and also, as far as this particular tutorial is concerned, seem to be giving plans if you ask it to give a plan for doing something. And so people have started writing papers on this stuff. And as I said, most of that has been written in the NLP and ML conferences. And there's kind of a bidirectional ignorance that's going on here. The people who wrote these papers in planning, they, look, I would just say it out loud that there's a whole number of people in AI currently who essentially, especially students, and among those of you here who are students, who are historic in the sense they more or less think that stuff started in 2013 and nothing existed before that. And then if stuff only started in 2013 in AI, then nobody talked about planning. And so planning must be something new that they are doing. And, so there has not been much of a connection to what else is going on anywhere else. So they didn't certainly, most of these papers have very few citations, for example, to ICAPS community, which you would think is doing a lot of work related to planning. And not to be left behind, ICAPS community is just equally, more or less ignorant of what's being done under the guise of planning in all these other places. Actually, one of the papers that I would be discussing, in the background, a whole bunch of things that I'm discussing in the background come from one of these papers that we submitted a preliminary version of it to ICAPS this year. And one of the reviewers basically said, the paper is good, but, we need more description of what LLMs are, and apparently, essentially, there are reviewers who haven't even heard about LLMs. And so I thought, hey, let's just try to do a little bit to reduce this bidirectional ignorance. So I'm giving a tutorial here. I might do this also at NeurIPS, something, just so that those people also will know what's going on. And my idea is to connect those two strands. And as it's been said about America and United Kingdom, that they are two great nations separated by a common language. These could be two strands of work that are separated by the common problem, the word called planning, except what those guys are doing, you won't consider planning and vice versa. So we'll try to sort of make that connection. And this tutorial is essentially an attempt to rectify this ignorance. And so it should be of interest to both populations. I'm giving it here, but I'm going to record it. I'm recording it. I'll make it up public. Hopefully other people will get it too. So the broad lessons of the tutorial, if you want to just remember this, is that we'll talk about both how large language models cannot do the kind of tasks that ICAPS folks will consider planning. Okay, so it's worthwhile understanding. I'll show you the proof of that. And yet, the fact that LLMs are available can change how you look at planning even in the ICAPS community. I know that there is no such thing as ICAPS community, but I'm just sort of looking at these people who show up to these conferences and then write papers in the ICAPS community. So it's both worthwhile in understanding that LLMs can't do certain kinds of planning tasks, especially what we consider planning they can't do. And then that LLM's availability will help increase the planning tasks that can be supported by us. One of the things I'll make clear later is that there are like two ways of living life. One is saying, I will only ever open my mouth if I know the answer with 100% certainty. And if you try to ask me questions outside of my expertise, I'll basically slap you. Okay, which is what we do if what you want to do as planning cannot be written in PDDL 7.975, we slap them saying, go get a life. We are real serious planning people. You should have talked to us in PDDL. Okay. But then if they do actually have it in that direction, you can actually give guarantees about correctness. Other hand, the other extreme is I'll answer any planning question and I'm not sure whether I'm right or wrong. And, I just free advice and you get to decide whether you want to take my advice. And I think in general planning community, the ICAPS community tended to be much more on the side of we want to prove correctness before we open mouth. And that sort of affects the usability of the technology for outsiders, because they would like to just say what their problem is and not care about whether or not it's actually in the language that you have. And and to the extent LLMs are available, periodically there have been pushes to kind of do this. I myself have done work on model-light planning, which basically try to say, let's just try to allow for models which are complete to models which are very partial, and then try to see what we can do in any kind of domain models that you have. And I'll try to explain to you that the availability of LLMs can actually increase the ability to do those kinds of tasks. So model-light planning, LLM in the era of LLMs is actually possible. So that's sort of the broad lessons of the tutorial. Okay, so here is the summary of the LLM roles in planning. I said saw, but it should be we will see, because I'm putting it out here, but it only makes sense as I think Schopenhauer, I believe, said, life only makes sense when looked back, but it has to be lived forward. Tutorials only make sense when looked back, but you have to go forward in the tutorial. So just to get a sense of where you will be, you will see, for example, how whether or not LLMs can be used to generate plans autonomously, whether they can be used to generate plans with the help of external planners verifiers, whether they can be used to extract planning knowledge, and whether they can be used as glorified natural language to some formal language constructors. So for example, you give like a English language sentence saying, put the block A on B and the block C on D, and then LLM essentially says on A, B, and on C, D with brackets, with parentheses. That seems like a silly thing to do, but that they can do. Essentially, they can translate things. So it's actually, these things have been used, and we will actually cover all of them too. A few caveats about the tutorial. It's not a dry chronological survey with a laundry list of papers and blurbs. By the way, I'll be showing you a whole bunch of tweets, because actually this tutorial was tweeted in last year and a half or something. And I basically sat down and wrote it into a tutorial. So that's a good way to live these days, because when you have an idea, and get people to understand the insight. But this particular thing actually is about survey papers. I know that many of you grad students, when you are running out of ideas, you'll say, hey, let's just submit a survey paper. And in fact, ICAPS helpfully started this survey paper track. And as easy as it is to write a survey paper, it may be easier to write a mediocre survey paper more easily than a mediocre original paper. But writing a good survey paper requires perspective on the area, which you rarely have when you're desperately reading papers and trying to put together some number of paragraphs. So that said, I basically take doing things like tutorials very seriously, in the sense, if I don't have a perspective and if I'm just going through a laundry list, it's not worth it. Okay, so yes, I do actually have a very specific perspective, and it's an opinionated perspective on the state of LLMs and the planning intersection, informed by our own work in the area. And what that also means that you have to keep as a caution is the authors of the papers, other than our own, which I mentioned, may not necessarily, may even bristle at the particular perspective or pigeonholing I am doing of their work. Tough luck for them. They are not in Prague, I'm in Prague. I get to actually tell you what their work is. But you don't need to, basically believe me. You can always look at this and then read the paper. And then when you read the paper, you at least know whether or not the perspective is making sense. That's basically the idea. So one of my favorite quotes is, the aim is not to make up your mind, but to open it, to make the agony of decision-making so intense that you can escape only by thinking. And so this tutorial is essentially trying to hopefully open your mind in terms of, don't just follow what people are saying in different abstracts of these papers, because they are actually, as I said, they don't certainly know ICAPS, and they also don't know what actually planning is. Different people are looking at different pieces of planning. And so this perspective might be of use for you. So the expectations on the tutorial audience, I'm sort of going to assume, because I'm in ICAPS, and it'll be insulting to ICAPS to think that there are people who don't understand anything about block-world planning, at least. So I'll assume that some understanding of planning as practiced in ICAPS is assumed, expected from you. That way you kind of know that. It's not like I'm asking you, do you know the papers in these proceedings? But I'm just saying, you know what sort of block-school planning, for example, sort of thing. And if you still have problems on that, do raise your hand, but that's what I'm going to expect. Not too much background on LLMs is going to be expected because I will give you a specific perspective on looking at LLMs that's very useful in thinking about whether or not they can do planning. Okay, I'm not going to tell you how to code. I'm not going to tell you how many layers are there in a particular transform architecture, but you look at LLMs as an n-gram model and steroids, and that is actually very helpful. Okay, so that's basically what the expectations are going to be. Okay, so now let me just start with a perspective on LLMs, even though it's about LLMs being used for planning. Basically, everybody thinks they understand what's going on in LLMs. And of course, internally, we don't really know what's happening, but at least externally, what's the best way of conceptualizing what huge pre-trained LLMs do? So as some of you may have heard about this already, but basically you think of large language models as n-gram models on steroids. Okay, n-gram models are these things, that have been around since the time of Claude Shannon, where basically you notice that there are statistical correlations in sequential data, especially sequential data like language. It actually started in language. And so if I tell you, I shook his right hand and you will think they will say something about the left hand, because just statistically, after you say right, you tend to say left. And so this is the kind of thing that you try to learn in just from large amounts of data. N-gram models that you have heard of before the advent of pre-trained large language models are typically small n-gram models. Unigram model, bigram model. Bigram model, basically given a word, can you predict the next word? Trigram model, given 2 words, can you predict the next word? Okay, and so if you think about it that way, ChatGPT is a ChatGPT, not the GPT-4, ChatGPT is a 3,000 word gram model, a 3,001 word gram model, because given approximately 3,000 previous words, can you predict the next word? And it's essentially trying to learn a conditional distribution over the, for any given set of 3,000 words, what's the conditional distribution as to the 3,001th word? Okay, and the distribution is over the vocabulary items. You can imagine that the approximate vocabulary is about 50,000 words in English. I'm going to be English-centric, because I actually speak Telugu, but I'm going to just speak in terms of English because that's what we are all using anyway as common. So essentially, that's the way you think in terms of what they're learning. So the power of n-gram model depends on how much text it trains on, how big is the n, which is the context, and how high capacity is the function that learns these conditional distributions. Why do you need a functional representation? Because you can actually write it as a count table. Essentially, if you think of naive-Bayes classifiers, you have thought of count tables, that the count tables become ginormous. In particular, if you're thinking of a 3,000 word sequence, then in the worst case, first word can be one of 50,000 words in the vocabulary, second word can be 50,000 words, third word can be 50,000 words. So you're talking about 50,000 power 3,000 rows in this count table. And not only is this count table ginormous, most of the probabilities you will learn would be degenerate. Because what is the chance that the same exact 3,000 word sequence will again come back? It's much easier for bigram model or a trigram model. Trigram model, the 2 words are again going to repeat some other time during the language. Whereas the exact same 3,000 words will almost never repeat. What that means is that for every one of these, there will only be one occurrence, which is basically a pretty dumb way of doing this count statistics. Instead, what you do is you represent this count table as a function, in a high dimensional function. And this function is going to approximate the counts and the frequencies. And when they approximate it, they basically turn the ones into something else and the zeros also into something else, and they'll become numbers, and you get to say they're generalized now. That's basically what generalization is as far as LLMs are concerned. Okay, so ChatGPT trains on approximately 600 gigabytes of text on the web, and it learns a very high capacity function that's about 175 billion parameters. I will talk about GPT-4 in case you are thinking, oh my God, Rav is only going to show that ChatGPT can't do planning. What about GPT-4? But for the LLM description, I'm just going to use the ChatGPT because, as you know, first of all, GPT-4 details, I mean, those of you who follow this, GPT-4 details are not public. And secondly, it doesn't even look like there's that much theoretical innovation there. There are all sorts of interesting hacks that they may have put together. Anyway, so that's what ChatGPT is doing. And essentially, it's learning this compact representation of these conditional distributions given the data. Okay, and one of the interesting things, this is important, is once it learns, then at any given point of time, if you give the 3,000 words at the context window, it already has a conditional distribution. It's not learning it anymore. And so those of you who have ever played with ChatGPT and prompting, when you do prompting, you're only just increasing the contents of the content window. So basically the window is shifting, the last 3,000 words that have been said. That just changes the conditional distribution. But the conditional distribution, as all conditional distributions, have been pre-computed. It's worthwhile remembering that. The way to change the conditional distributions is this stuff called fine-tuning. We will do both of them in terms of planning, but that's the two usual ways of doing LLMs. This is a funny example, but I won't go through it, but I'm assuming most of you know that essentially they're called self-supervised, but really just simple autoregressive learning. So given you have all the data, all the English on the web, in fact, it has nothing to do with words. It's any sequential tokens. And what it does is it tries to look at K, the words, and then try to predict the K plus one word. And then it checks whether the word it predicted is the same one as the one that is actually in the text. And if not, there's an error, it backpropagates. Okay, and by now, you know that these words can be represented in high dimensional spaces. That's the usual way people are doing this stuff. And then there can be error between the two vectors. And this error is propagated through backpropagation. And, and essentially over a gazillion epochs, weights sort of reach some sort of a local minimum. Okay, as I said, the count table is ginormous and also extremely sparse because the same 3,000 words are likely not to ever reoccur again. And so transformers turn out to be a way you represent the approximate function. And as big as 175 billion parameters of transformers looks, compare that to 50,000 power 3,000. I compared it. You ask Google, what is 50,000 for 3,000? It says infinity. It's way too big a number. Okay, 176 billion is just 176 billion. So that's the way to think about it. The approximation functions are actually hugely saving by, in lossy compression. Okay, so that's what is being said. And what LLMs are doing is compress, approximate this ginormous count table with a function. And it's worthwhile keeping this in mind because that's what we're going to be using later on. And the function learns to sort of abstract and cluster over similar sequences. That's intuitively the same thing to think about. So imagine you have a 3,000 words, and in one place it said heart, like the 79th word is heart. And then I got another 3,000 word sequence, exactly the same words, except the 79th word is scalding. Heart and scalding are similar in the word space, right? And so you might consider this, it occurred again second time. And that sort of increases your non-zero entries in the count table. So that's a way of looking up, thinking about what's happening there. And then once, of course, these 76 billion parameters are being computed, the ChatGPT is essentially being trained on 600 gigabytes of text on the web, which is approximately 60 million pages of text. This text is what we wrote and uploaded for our consumption. This is extremely important to understand. If I now tell you that, Microsoft gave me $20 billion, you guys start putting everything that you're ever talking on the web, you'll say, screw you. We have life to do. But since we already did it, you would get to use it. And of course, after the fact, then we can complain saying, no, we never said that you can use our data to train ChatGPT. That's what we're doing, but it's already there. So it learns this high capacity function. It requires extreme compute facilities to learn the function. There are things that are improving, but this is a funny picture which shows that at the way about 6 months back, the compute requirements of large language models were going. By about the middle of 2026, the amount of money required to train the next model would be more than the GDP of USA. Okay, that was the fun part. There are, of course, more interesting engineering things are going on. Those of you who are keeping track of this realize that size is not everything. In fact, smaller models sometimes can have pretty useful performance on smaller tasks, like narrowly scoped tasks. And Llama has let 1,000 flowers bloom. Llama is this small model that they trained whose weights got leaked and people started playing with it. Okay, so ChatGPT, that's all. And by the way, so that's like the only picture that you will see for transformer architecture. I'm not going to tell you what transformer architecture is because that's not what this talk is about. But it's kind of useful to understand how ad hoc the whole thing is. Ultimately, it works is what we are happy about. In fact, one of the interesting things is transformer architectures don't actually have a way of keeping track of the positional information of the word. There are great languages, such as mine, where the word's position is not as important. I can put the word in different places and still actually change the ending of the word so that the meaning remains the same. English isn't one of them. English, the position of the word means everything. So what do? Essentially, they take the word embedding, whatever this high-dimensional vector that you learned for the words, and then add to it some arbitrary epsilon, which is dependent on the position. So it's like apple plus a little bit of orange, and that will become like the positionally, context-sensitive word encoding. That's what they're going to be using. And it's not, is it any reasonable thing to do? Not really, but is it working? Yeah, it seems to be working. But how did you define working? You just wanted to predict the next word. Okay, so the ChatGPT is completing your prompt by repeatedly predicting the next word given the previous 3,000 words, but the function learns to predict is this high capacity function. And then the interesting part is, oh, that's all. But then all conversation, when we're talking to each other, it's like I tell you a whole bunch of blah, 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 blah. And then you say something blah, 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 blah. I mean, each of these blah is a vocabulary item. And then we are continuing. So from an outsider's perspective, conversation is essentially completing in the context of previously spoken words. And the bigger the context window, the more interesting the conversation will start sounding. Okay, so ChatGPT can converse with you on any subject. Really? Yeah, actually, really sort of, depending on what you're looking at. It can, as all of you know, it can do things like writing an essay, writing a poem, giving explanations, and also, this is apparently the thing that we are supposed to be very worried about. It can actually generate a unicorn using TIGZ code sketch. Okay, I don't know exactly when we decided that this is a sign of intelligence, but neither did I know when we decided playing chess is a sign of intelligence. Those are the things that we have basically been impressed. It's more a question of what are we impressed with. If there is any meaning with any of the completions that ChatGPT is doing, it is completely in the eye of the beholder. There was no guarantee that it was doing anything more than predicting the next words such that the new sentences it is generating are approximately in the same distribution as the distribution over which the entire public web data has been lying around. That's all is the guarantee. So you're in the manifold. So one way of thinking about it is that movies are in the manifold of reality. They're not real, but they're in the manifold of reality. Okay, so if it's completely not in the manifold of reality, you would not actually see the movies because they don't make any sense to you. But if you start believing everything in the movie, thinking it actually happened yesterday, then you are in trouble. So if you start believing that whatever ChatGPT tells you, then you are in the same trouble. Okay, so the interesting question is, how can this prompt completion base generate such coherent, plausible text as to make lots of us think that they're doing actual writing, I haven't started talking about planning, but they seem to be doing all these other things. Exactly why is that they're able to do? The answer, magic. Beyond saying that essentially we are playing with these conditional distributions over 3,000 word window, I can't really say anything more. In fact, it's become the entire work on ChatGPT style stuff has become an ersatz natural science. There are no proofs, there are no theorems. Imagine you are walking around in this, in the grounds of Prague University, you find a strange looking animal. You don't know what the heck it is. You didn't make the animal, but so you start poking it to see what sorts of things it does, and you get to write some papers in zoology journals. ChatGPT has become that. We actually happen to train it, but we have no idea what we trained it for. And it seems to be when you poke by doing these prompts, it's doing various things, you get to write a paper for each type of prompt. And it's become a great cottage industry to write this stuff. Okay, every day, like ChatGPT can do law, ChatGPT can do medicine, ChatGPT do something else, etc. And that's become the case. And the sad part of research natural science is that we were not really trained as natural scientists in computer science. So they actually, biologists know how to do reasonable statistical analysis when they are making these kinds of studies, and we don't do it. And so oftentimes people actually confound causation and correlation and start writing papers, and that's something that will come out today. But in terms of understanding at least a little bit as to why it is able to actually come up with interesting completions, some possible factors you want to keep in mind is almost everything we know is already on the web. And you really don't know all the junk that's on the web. In fact, as I'll point out later, one of the things is, we think that we know how three-dimensional spheres look, and so we kind of tend to visualize four-dimensional spheres, five-dimensional spheres, 10,000 dimensional spheres. And we think, yeah, they'll just be like spheres. I can't exactly make one, but they're like spheres. And then, of course, your intuitions are screwed, because if you peel a sphere, a three-dimensional apple, then you still have most of the apple left. And many of you know that if you were to actually find a 10,000 dimensional apple and you peel epsilon peel, there's no apple left. Right? Because it's r minus epsilon by r power 10,000, and that would be very close to zero. That's the remaining volume. So again, our intuitions are just not well suited for high dimensions. Our intuitions are also not well suited for approximate omniscience. Something that has been trained on the entire web level data, you have no idea what is actually there, how much data contamination is there. Is it really more or less retrieving what it's been told before? And since I said the word retrieving, I should mention, just to begin on the same page, that large language models don't index and retrieve. They're not databases. Okay, they are instead just our n-gram models. N-gram model essentially is approximately remembering the structure in the data it has seen in terms of these conditional distribution tables. It can never really able to come across, reproduce an entire passage, which surprisingly, while it is actually, we have the same problem, we actually have non-veridical memories. And so we would never remember exactly what happened. When we retell it, we are stitching pieces together. And so we have faulty memories, because of which witnesses are considered to be, very fallible in the judicial system. In the case of large language models, the very fact that it cannot remember and reproduce exactly has been seen as like, wow, that's so damn creative. I never wrote this essay, and yet it came up with this essay. But what if, in fact, there are enough essays on cows, enough essays on Tolstoy's influence on the Second World War politics? You would say, oh, no, there's no such essay. How do you know? Have you read the 600 gigabytes of text on the web? Have you read, for example, the websites which will explain jokes? If you read a joke and you don't know whether to laugh or not, for humor challenged people, there are websites that explain why you are supposed to laugh at this point. And they exist. And if, in fact, this stuff has been trained on that, it will explain joke back to you. Not exactly by retrieving, but that's point to keep in mind. So, and the other thing is that we don't have intuitions over completions over large context windows, as I've already pointed out. And that might be the reason we are surprised. And the last thing about the LLM part before we jump into the planning part is, if you have a pre-trained LLM and somehow you want to use it in a particular area, in our case, we want to use it in planning, let's say, and you're not too happy with what it's saying, you are not yet just blindly, believing whatever it said, and you're trying to, make sense of it. So the question is, how do you improve its responses for this particular narrow task? There are two useful approaches that people follow. One is prompting, which is essentially after it says something, you say something more in the prompt window. And when you did this, the context has changed. The last 3,000 words now include whatever it said plus whatever you said. Because the context changed, the conditional distribution changes. But it's not learning in any traditional sense. It didn't actually change any of the parameters. The parameters have already been computed, and they were enough to essentially tell you for any 3,000 words, what would be the conditional distribution about the next word. And this has been called in-context learning, and this is basically the way people use GPT-style stuff. Okay, so you basically, it says something, then you say something, then it says something, then you say something. And one reason this is a natural thing for us is that's what we do to each other. You know, when you're trying to tell a kid how to answer a question, the kid will give an answer. Then you say, no, do you consider this? Then the kid will come up with a new answer. Then you say, no, do you consider this? Until you keep doing this until the kid gives the right answer. There, it's a good idea because you're trying to somehow teach the kid how to reason. In the case of LLMs, we have shifted from there to believing what the LLM tells you. So at some point of time, you start believing what the kid is saying. And if you can only do that if you know the answer to begin with. Do you understand what I'm saying? You can't prompt somebody to tell the right thing if you don't know what the right thing is. Okay, it's a very useful thing to remember. And so there is the undeniable attraction of prompting is that it's natural for us. It's sort of how we interact with each other, because of which there's a whole cottage industry of the art of good prompting. That's kind of how to ask an LLM nicely to solve my problem. The way you try to do with people, except you're not doing it with the people and it's saying something and it's always in perfect grammatically correct English. The real question is, do you believe it or not? Well, if you know the answer, you can check. If you don't, all bets are off. Okay, that's about the prompting part. The fine-tuning part is the other one where you actually take a break, get a huge amount of data on which that you want to improve the LLM's performance, and you essentially do additional fine-tuning training where the 176 billion parameters are changed. Some of them get changed. When they get changed, actually the conditional distributions now for the same 3,000 word window would have changed. You see what I'm saying? So that is actually changing the internal parameters. The first one is not changing anything. It's just basically changing the context. Okay. And if you do this, sometimes you can make permanent changes to the LLM. One of the interesting problems is when you do, this is like lobotomizing an LLM. And when you do lobotomizing of the LLM, yes, it might do well on the task that you are training it on, but its performance on the other tasks might go down. Which is actually, hilariously was sort of claimed by Microsoft researchers who played with GPT-4 and saying it has sparks of AGI. But then if you hear Sebastian Bubeck give that talk, he says, don't try these at home because it no longer does it. Why? Because after they did it, apparently, OpenAI fine-tuned it to be less offensive. And then it became less offensive, it became less brilliant. No more sparks of AGI. Okay, but you can laugh at it, but you should understand also that when you're changing, then when you're changing on the prompting side, you change the prompt, you get a different conditional distribution. Nothing internally is changing. Whereas if you're doing the fine-tuning, you're changing the internal weights, and that's a much bigger deal that you're doing. Okay, and the last thing is that our pure intuitions, as I mentioned about pure intuitions about approximate omniscience, make it hard to tell whether LLMs are reasoning or retrieving. In general, it's actually hard if you ask somebody a question and they give it the answer, you happen to know that answer, let's say, for the question. Do you know whether they reasoned from first principles to give the answer, or have they heard this question possibly like 10 days back and they remember the answer? There's no way of proving. And humans will always claim, oh, I just, of course, did first principles reasoning. Nobody will ever say, oh, I heard the question already. Do you understand what I'm saying? So in general, it's extremely hard to prove whether something has been right by retrieval or right by reasoning. And it becomes bigger problem with LLMs because most of it could just be, if you're trying to understand whether they have planning abilities, what is a planning ability? If it gives a correct plan, is that planning ability? Or if it actually puts together things from first principles to make a plan when such a plan has never been encountered before, is that considered planning ability? And actually figuring this out becomes a big issue. This is part of the reason why people get confused as to, oh, it has all these abilities, and then you try to do something and it doesn't have those abilities. So in fact, as I would say, it like you need, like the miracles, you need to believe before you can start seeing LLMs show sparks of AGI. Because otherwise, essentially, you would just look at the answer and then actually coldly compare it to the real answer that you're looking at, and you can't tell whether or not, in fact, it's a reason. So that's something that, and in general, memory reduces the need to reason from first principles. This is an extremely useful thing for you to remember. The reason you are actually doing reasoning from first principles is because you have a life and you have a small brain, and you want to use that small brain to do other stuff. If all your life is to just do well on a damn exam and you have no life, you would basically read up every possible question that has ever been set for that kind of an exam. At which point, when you come into the exam, it's just a repetition. Entire professors, including the ones sitting here, depend on the fact that you don't do that because you have a life. And you will be sometimes forced to do from first principles reasoning. For LLMs, that's not a problem at all because they have like basically humongous amounts of memory, and they have looked at the entire data on the web. And so coming up with new questions are actually very hard. For those of you who are teachers, you know that as students are complaining that, oh, exams are painful, like all these questions that I can't answer. Professors are complaining, exams are painful. I have to set questions that aren't already available on the publicly available question banks that the students are going to pay money and get. And so they no longer know how to reason, they just know how to pay the money to get the answers to the questions. And the question then is, in the case of LLMs, is that what is happening? I mean, it's not that LLM is paying the money, but was it there in the original data? And that's 600 gigabytes of data. You have no real idea what is there and what is not there. And so this is worthwhile keeping in mind when you hear all these claims about LLMs, acing the LSAT and GRE and SAT, etc. Because the one thing that standardized exams have is the standardized question bank. Tons and tons of people have remembered all the questions and written them down. And those of you who have taken exams know that there are these places where you can get all these things on 4chan or something. And then the teachers are trying to say, no, please don't go there because that's where our questions are. In US, for example, ETS, Educational Testing Service, says you are not allowed to remember and reproduce the questions in the exam that you have taken. How dare they control your memory after the damn exam? It's because it's a monopoly, it was getting away with it. You understand what I'm saying? In general, if you remember, and if each of us remember 5 questions and come back and write down the questions, then nobody ever has to study for the exams, if also they have big brains. That's what is happening with LLMs. Keep all of those in mind. Now we get to, can LLMs plan? Okay. So my first thing I try to do is ask, everybody was out, I was already reading a lot of papers saying LLMs can do planning. I'll show you some of those things, not written by me. And so I said, hey, I'm an ICAPS guy, if they can do planning, they should be able to do Sussman anomaly. And those of you who are born, who basically haven't kept track, that's Sussman anomaly. C on A and B is on table, and you want to put A on B and C. And it was considered anomaly because this ICAPS, I'll at least tell you that it was considered anomaly by Sussman because there is no serialization order. If you were to give the goals to be on A, B, and on B, C, there is no serialized order in which you can achieve on A, B, and then achieve on B, C and stop, or achieve on B, C, and then achieve on A, B, and stop, and reach the goal state. In either which way you fail. In essence, so then all sorts of interesting terms were invented, such as creative destruction. So you have to make the goal and then undo it just to reach the final goal, etc. But nowadays our planners deal with it anyway because we don't do serialization anymore. But it was considered a cute example. So I asked LLM, here is my discussion with it since the slides are available, and if you have no work, you can look at it, and you can also have a conversation with the ChatGPT. And so it just basically keeps making mistakes. And one of the interesting things is ChatGPT never shows lack of confidence. It's the know-it-all. It's just basically the same level of magisterial tone. It will give an answer. And if you don't know it, sounds good, man. In fact, remember, most of what English teachers were doing is looking at essays and seeing if it is written in good English and hoping that means that will be a good essay. And that's why they are the bunch that are extremely worried because of ChatGPT, because everything is well written. The question is content now, and it's much harder to look at. So I had no work that day. So I was actually looking at what ChatGPT is saying for the blocks world. And here is continuing my this thing, and the next page. And it keeps making mistakes and saying, I'm done. And then say, no, you haven't done. And I show the problem it's making. And so then finally say, okay, then I'll do this, etc. Now, by the end of which, it's no longer clear that it did planning, or I nudged until it gave me the answer that I was expecting. Do you understand what I'm saying? And if this is what passes for planning, then anybody can do planning, right? So in general, so I tweeted at that point that forget ChatGPT, forget Super Bowl. It's more fun to watch the powerful ChatGPT to plan, trying to plan a 3-block stacking configuration. And TLDR, LLMs are multi-shot apologetic planners that would rather use you as their world model come debugger. That's exactly what they do. If you from our terminology, that's what they're doing. They'll give something and, remember what is the dumbest way, what was the simplest way of doing any intelligent thing? Generate and have a jobless guy test. And if the jobless guy says, no, this is wrong, generate again, have the jobless guy test again. And if you keep doing this, maybe one day, you might actually turn up on the correct answer. Is that considered knowing how to solve the problem? Hopefully you realize that's not the way you're supposed to solve problems, but that sometimes can be, what is being taken to be the science of planning abilities. Okay, so that was the case. So that happened in the 3 blocks problem. In particular here, I actually had a normal conversation. So after that, approximately playing with the timeline a little bit, we actually formally did a study on the GPT-3 at that time. It's not even ChatGPT, GPT-3, on whether it can take problems in the IPC competition and give the solutions. And IPC competitions are simple planning problems, and so can they do it? And Bloxworld was just one of them. And as I'll tell you in a minute, basically the way we would prompt it would be, we'll give it the domain, we'll give it the initial state, we'll give it the goal state, and say, give me the plan. And sometimes we'll give the domain, initial state, goal state. Here is a couple of problems and the example plans. Here is a couple of problems, example plans. If you do that, it's called K-shot learning. If you don't give any example, then it's just 0-shot learning. That's the terminology that's used. So we tried both of those, and we essentially found that it actually doesn't perform planning at all. In the sense that it's basically extremely bad in generating correct plans. We know how to check this because these are IPC domains. There are val working off of the domain models, and you can check whether it's correct or wrong. And this correct or wrong is binary. There's no partial credit, right? And it turns out that it's actually mostly wrong. So then this became surprising to those people who thought that planning can be done by LLMs. And so in fact, it was written up, there's this general, suspension of disbelief in, as far as LLMs are considered. People tend to think, oh, I'm sure, unless proven otherwise, they will do everything. And so if you actually show that they don't do anything, it is news. Certainly, okay? So it was written up, and then, other people agreed that, yeah, of course, it makes sense. I mean, those people who have a clue of what ChatGPT actually does, but everybody is an expert on ChatGPT now. And so those people were thinking, why can't they do this? Okay, now that after that, GPT-4 came along, and then Microsoft wrote this AGI Sparks paper, right? And it's sparking all the way. And so the question is, will it be able to do any better on the same test that we did? Right? It's a reasonable thing. So this time, actually, this is a paper that, that paper is on the web, but this paper is the newer version. It's also on the web. I'll show you the archive later. But it basically, we set up this more systematic framework. Essentially, you have a way of considering one-shot or 1-shot or 0-shot or K-shot, prompts, and also whether the prompting is in English, that is pseudo-English, or is it in PDDL? One of the things that we have to understand is, as far as the LLM is concerned, English and PDDL are the same. They're essentially a sequence of tokens. Okay, for you, it might make a big difference, but it doesn't make a big difference for them. So you can prompt in a PDL, or you can prompt in English, and then use allowed for all of this, in an infrastructure. And then the prompt, given a problem, we take it from IPC test suite, which we generate random, like 500 problems per each domain, generate a prompt in the format that we want, and then give it to language model and ask Val to check whether the plan is correct. Everything is automated while we go have coffee. right? So we have a life still. And so this is basically doing it autonomously. So it turns out that by this time, previously I talked about GPT-3. Now in this picture, you can see Instruct GPT-3, which is better version of GPT-3, better in the sense it was supposed to be less offensive. It was fine-tuned in either supervised or reinforcement learning approaches to actually have slightly different weights. And that's giving less offensive completions, but of course, what it changed in other places, we have no idea. So we actually checked about their planning capabilities. So GPT-3 Instruct GPT-3 was slightly better in guessing the plans. I mean, I'll use the word guessing because I have no reason to believe it is reasoning. And then GPT-4 went up to 34%. And you might just say, well, today 34%, GPT 4.5, 100%, after that 200% correct. That's the way the exponential improvement in AI works, right? So that it's still bad. 34 is bad, but it seems like a big improvement. In fact, these are more results on the same type of models. We actually played with lots of models, including, of course, the OpenAI ones, and also Bloom, and also some of the public domain models, and you can play with these things anyway. And so those are the numbers. And just to give you how the prompt looks, I said how I would do the prompts. So the prompts basically look like, if I write it in the natural language, the domain is described, basically direct conversion from PDL to like a pseudo English. And you have a query instance. And then you can give examples here, which is basically, here is my initial state, goal state, and this is a plan. And give me a plan for this new initial state, goal state. That's what I'm asking. Now, again, remember that think of this as a big context window in the context of which it is now going to start writing its plan. Essentially, that's what is happening, okay? And then, of course, if it becomes, if the plan that it gives out, you check whether it's correct or wrong, and then, automatically position. And it turns out that even this 34%, you might just say, well, maybe Bloxwald plan is one of the funny things that, as I said, NeurIPS people who make these claims and the people who are making these claims about planning abilities of LLMs, they have never heard of ICAPS. They have never heard of Bloxwald either. In fact, some of them have started hearing about Bloxwald, and so that's the interesting consequences there. But so they might basically say, well, this is not planning. And again, for ICAPS community, ask yourself the following thing. How many times in a typical day have you heard the word planning being mentioned by people outside of ICAPS? And how many of those times what they said planning corresponds to PDDL specification of planning problems? Not a question of whether or not it can be converted to PDDL. Use the word planning in a lot more general scenarios than stacking blocks. We, this community, actually tend to do stacking blocks as like one example of planning, okay? So people might be thinking, many people outside might be thinking planning means planning a wedding, planning a party, planning like an election campaign. These are also considered planning. Do you understand what I'm saying? They don't have a binary notion of correctness. And so if you ask GPT-4, how do I plan a wedding? It'll give you a nice little perfectly written English stuff. And then you say, oh, that looks like a good thing. In fact, many people say, I'm spending some time in Prague. Can you give me a travel plan for Prague? And it gives it and says, screw Rao, GPT-4 is great. It gives me a way to travel in Prague. You could have Googled the damn thing, that, right? I mean, it was there in the web. It's not making stuff by putting things together. It was just basically approximate retrieval. And that's very different from essentially having to solve a problem under the constraints that I'm providing you. So people, not surprisingly, I mean, this is something that you'd be very impressed at. In this community, people will say, get out of Bloxwald already. It's so simple. We had people tell the reviewers, say, maybe Bloxwald is very hard. People can't do Bloxwald. Okay, so how do you know that GPT-4 is much worse than people? So we actually, this may well be the first time ever, we did study of the mechanical Turkers solving Bloxwald problems, the same ones that we are giving GPT-4. Okay, and the Turkers are not well paid. I'm sure you guys would have got 100%, but even the Turkers got 78% accuracy. This is worthwhile remembering. Okay, so it still looks like 34 is not too bad, half of the thing. Now ask the following question, and this kind of, you should be primed by now, that are LLMs retrieving based on all the stuff that they have seen before, something like a wedding plan. You guys don't write as much stuff on the web, but IPC benchmarks are all on the web. And they don't have to ask multi-helmet for license to train on that data. So in fact, all this stuff has been trained on. You understand what I'm saying? So the question is, what if they're really just retrieving using these common sense patterns rather than reasoning? Remember, it's extremely hard to tell whether people are retrieving or reasoning. You should be careful. You should be particularly smart in checking this testing. So one thing that we did is mystery domains. So Bloxworld, actually this stuff written on Bloxworld, right? Because on the web. And people talk about blocks and stacking stuff and putting stuff on top of each other, etc. So what we did is what Drew McDermott, who passed away, recently in the 1998 competition, he was worried that people will cheat because we wanted domain-independent planning. And he was worried that maybe people will write domain-dependent planners and say, if the word is Bloxworld, use this algorithm. If the word is something else, use this algorithm. And actually, I won't go into the gory details, but later on down the IPC line history, there was somebody who actually did that. You can go up and look up the history. But, Drew McDermott was worried about it, so he did the mystery thing. We did the same mystery thing for GPT-4. So what did we do here? We basically, if you can read this, pick up a block becomes attack object. Okay, unstack a block from the top of another block becomes feast object from another object. So we used English words which have meaning, but they won't tell you what the actual action in terms of English semantics is. And those of you in this room know that if you know how to do reasoning, if A is true and A implies B is true, then B is true. And that doesn't depend on the syntactic naming of A and B, right? So reasoning doesn't depend on the name. That's what Shakespeare said, that, a rose by any name sounds just as sweet. And you should be able to reason even in this. And all our planners reason on this mystery domain with 100% accuracy. You guys know this, right? So the question then is, if I give it to GPT-4, what happens? Well, what happens is that it gets a nice 1 out of 600 performance, or 0.16% on the 0 shot and 2.6% on the 1 shot. And the one mystery box called randomized essentially, instead of actually using meaning-bearing words, we use random strings. And once again, what you're doing is, in the second case, there won't be anything that you can do directly by pattern matching. In the first case, you'll get the wrong associations because these are words that are English words, but you're getting wrong associations. And so if you are actually cheating by associating, then you will be seen. I can't prove that GPT-4 is doing it, but this is the proof. Basically, it does very, very badly. Do you understand what I'm saying? So it can't plan. So plan generation results, this more information on plan generation results on mystery domain. And we did mystery domains for other things like logistics, et cetera, et cetera. It just fails. So it's not planning. So in fact, when this happened, I tweeted that, if you're afraid of GPT-4 going rogue and killing everybody, worry not. Planning has got your back. You can ask it to solve any simple few-step classical planning problem and snuff that AGI spark well and good, because it can't solve them if life depended on it. That's at least the case, right? And it was actually, again, it was basically people agreed that this is a reasonable test. And in fact, we know that it doesn't actually plan, at least the way we think about planning. No, other question is, can alternate prompting strategies help? If I asked it more nicely, maybe I was being rude to GPT-4. Maybe if I asked it more nicely, we would have given it. Okay, so we actually considered plan generation in PDDL prompting as against pseudo natural language prompting. Things don't change that much. Okay, we did that part. Okay, and in fact, I think some other people also have done PDDL prompting separately. In fact, one of the nice things is after we did this, at least 2 other groups have independently done the same experiments, and I got the same results, similar results. That means GPT-4 can't plan. Okay, do we have to include one thing that while you're sitting here, and this is actually the first time I'll get you some related work in, you might be thinking, why are you telling it what the domain is? Remember, when I showed you the prompt, one of the prompts that I show is basically I'm giving the domain, either in a PDDL or in language. Okay, so why should we do it? Why can't just ask without giving the domain? Give me a plan for stacking A and B and C, which is more or less what I did in that text description when I played with ChatGPT. That's what you would probably do. But the thing to remember is if you do not give the domain model, LLMs come out with some English description of what looks like a plan, and it might be maybe referring to what look like action names that don't even exist in the executor's repertoire of actions. Do you understand what I'm saying? So suppose it might just say, put A and B, and if your domain is only knows how to do stacking, then you have to figure out, oh, putting basically means stacking. Okay, so in general, if I give the domain, then at least I make sure that the constraint is you're supposed to use the actions that are available, which is a very reasonable thing to do in planning. If you just prompt LLMs with just the problem, then the actions output by LLM may not correspond to any actual actions that the executor has access to. There are two ways of solving the problem, and people have tried this and written papers separately. And before we actually showed this, okay? One of which is just look for an action close or similar in the name, either in English or in the embedding space, and hope for the best and say that's probably what the planner had in mind. Is it making sense? No, it doesn't make any sense, but you're just trying to read tea leaves about the output that the LLM is giving. You could write papers on this. They'll actually show you a paper in a minute. The other is manipulate the next token such that the actions that are generated are essentially compared to the available actions in terms of the probability of actual success, and use that to you're manipulating the conditional distribution of the actions external to the LLM. And that is actually the very first idea that was tried in trying to do planning with LLMs. The SACAN approach that was done in Google, which basically said LLMs can do robotics planning, this is what they did. And to do this manipulating of the next token, you will need access to the innards of the LLM, because you need to know the actual probabilities stored in the conditional distribution. You understand what I'm saying? You guys don't have that access. If you get ChatGPT access, you don't get that numbers. If you're in Google, you have that. That's actually unnecessary, it turns out. If you want to constrain its actions, just give the domain model. That's a much more natural thing to do. And so this is a paper that, in the PMLR, it's pretty prestigious place, which essentially looks at LLMs as zero-shot planners and tries to make sense of the plans they generate by comparing the action names to the actual action names in some space, either direct, syntactic space or the embedding space. Doesn't make too much sense, but there's a paper in PMLR. And when you're reading this, this perspective might help you figure out whether or not you think it's a significant enough result. And then SACAN, as I said, that's one of the first papers. It's been actually, multiply cited very well, and it actually got like the best paper award in Coral, which is the one of the prestigious conferences in robot learning and planning. And as I said, they are essentially using LLMs only as a heuristic in terms of what are the possible actions you can do. And in fact, they use an external simulator, which means it's a domain model because simulators have to be written by somebody. And you are basically saying, okay, what are you saying and what can I do? And multiply these to look for the action that is actually easily doable. And it's also you're giving a reasonable probability for that action or the name in your conditional distribution table. That's basically what SACAN does. There's a humongous amount of description, but that's basically what it winds up doing. And as I said, to do this, you need to have access to the inner conditional distribution values, which I don't need. In fact, I just give the domain, I would be fine. Okay? So there is your connection with my way of looking at the world, your connection to reasonably well-regarded paper and how it does. And in fact, I actually like SACAN in one sense that at least it realizes that LLMs don't do planning. LLMs are being used in the process of doing planning, where there is a simulator and there is an RL system. And essentially, you're just trying to tell that system, agent, which actions to try next. And in fact, I'll tell you in a minute that you can use LLMs as heuristics, and that's a pretty useful way of using them. There is no problem with that. But here I brought up SACAN to just tell you that if you don't want to give a domain model, one weird way is to actually have access to what it was about to say. So if I basically open your head and then try to say, what were you about to say? And then what can I do? Multiply these two probabilities and say, okay, this is what I want you to say now. That doesn't make any sense to me. Okay. Will LLMs do better if they do step-by-step plan generation? One of the big claims, and in some sense, it's not a bad idea, because remember, LLMs are essentially in context learning, which is the prompting-based learning. Their conditional distribution changes based on what are stuff that you have written. If you write magically the right words, maybe the conditional distribution will be the right, closer to what you're hoping for, and it will start outputting the right words. One thing that people have started thinking about is, if it does somehow step-by-step reasoning. So instead of just saying, what is a plan? Give me a plan. You tell it how to do planning. I mean, this is a whole capital thing, give a man fish and he eats for a day. Teach a man how to fish, he eats for a whole life. I don't know why the heck people want to eat fish. I'm a vegetarian, but that's the thing that people say. And so the question then is, what if we tell LLM in English how to do planning? In particular, all I really need to do is to tell LLM, okay, for a plan to be considered correct, this is the way you prove to yourself. This is what you have been told when you took planning classes. Because how do you verify a plan? There are essentially like 3 standard ways: are progression proof, regression proof, partial causal link based proof. And you use one of them to prove to yourself that the plan you have on hand is actually correct with respect to the domain model. And if you're done, then you're done. So can you do this? Well, there are 2 ways of doing it. One is I can say, let the LLM come up with a plan and say, did you notice, LLM, that this action is not having its precondition supported? And it'll give you another plan. Then I'll say, no, did you notice that this other thing is missing? And I keep nudging it until it gives the right word, right plan. If I do that, then I'm doing what the example that I started with, which is LLM is not solving the problem. I'm making the LLM solve the problem using my time when I know the answer. If I don't know the answer, I can't be able to do it, right? The other is I actually act as if, take it on its word and say, I will tell you a meta prompt, okay, saying what makes the plan correct. And that will also be in English. And let's see how far you get with it. Okay. And that's exactly what we did. And when we did that, basically, this is basically state tracking. So when you do, one way of doing it is state tracking. So think of initial state, say an action, look at the next state, say an action, only do the next action if it's actually applicable in the next state. That's what you guys do, right? In terms of generating plans. Tell that whole story. So here's an even bigger prompt right now, telling it, how to do planning, right? Does it help? No, it doesn't help. So basically, when you give the state tracking kind of prompts, examples, and in fact, the details, you can look at this more carefully, and I'll also show you the paper. If you do that, it doesn't help. And yet, most of the literature on LLMs is rife with these claims that chain of thought prompting. Can just show me by show of hands, how many of you have heard of chain of thought prompting? Okay, this is ICAPS conference. People don't need to know this, but you still know a chain of thought prompting, because it seems like that's a miracle cure. Like for the baldness miracle cure, chain of thought prompting is the miracle cure for taking care of all the problems of LLM. No, it's actually you solving the problem for LLM and telling your boss that LLM did solve it. Okay, and that's the way to look at it, because the way I would do, actual state tracking thing is I'll tell you what states are and you try to use it. For doing that, you actually have to do reasoning at a different level. And we know, I mean, again, one of the things I want to tell you is I started doing this line of work, almost I had to be dragged into doing it because I knew that they can't do reasoning. And yet every people around me were believing that they can, and I had to prove to them. It's kind of an unnecessary thing to prove. But it turns out that once I proved this, I actually found the other useful things that you can do with LLMs in the context of planning, which I'll share with you. Okay, so both are useful things. So it turns out that actually the numbers show that COT doesn't really improve much at all. It's basically noise in terms of, if I do COT this way. If on the other hand, you can find completely jobless humans who do step-by-step correction of what the LLM is doing, then all bets are off. Do you see what I'm saying? If I keep asking you to come up with the next plan, with the human students, they will lose patience and they'll say, no, I want to go for a movie right now. For LLM, there's no movie to go to. So you'll just keep giving next answer. Since you also decided not to have a life, eventually you may actually get the correct answer. Then you can say, wow, LLM solved it. But no, you actually just wasted your life. And in fact, for it to be correct, you should have known that it is correct. And I'll actually bring up this point about clever hands, which is this horse from Germany in the turn of century, which used to do arithmetic. And it turns out that it was doing arithmetic, not because it knew numbers, but because it could sense the level of anxiety of its owner when it came to the correct answer. So for example, if you do 4 + 3, it will stomp its legs 7 times. And what it was really sensing, it turned out, as people have found out later on by systematic examination, that as it came to 6 stomps, the anxiety level of the owner will increase. And it will sense that and will stop after 7 stomps. So the question is it doing arithmetic? No, it is actually sensing your anxiety level. And you know the arithmetic. Okay, and that's the way to think about chain of thought reasoning with humans intimately involved in it. And it's a very useful thing to keep in mind, especially for reasoning tasks. What if we fine-tuned LLMs with successful plans in the domain? And I'm giving it all possible benefits out to see whether, in fact, it can do anything. So essentially, in addition to just pre-trained, maybe they didn't do enough planning things. So I will try to give more extra block-solved plans to it so that it'll know patterns in the block-solved plans, and it'll try to kind of generate the next action based on that. From a learning perspective, that should be possible. If you just somehow find that giving the block-solved domain model is much harder than giving a trillion block-solved initial state, goal state, and correct action sequences, if you are one of those people who believe that is a reasonable thing to do, you can actually do that. The learning system will learn to predict the next token. It's just that, in fact, it's been done before, including ourselves. I'll show you in a minute, but now we are doing it in the context of pre-trained model. That means it already knows significant amount of information about how to, predict next word in the context of a global vocabulary. And the question is it going to learn from much fewer examples? We tried and we didn't really get much of an improvement. And first of all, it's a waste of time to do this fine-tuning on just a specific domain, because you might as well just at that point say, use the planner instead. Okay. Other people have tried this too, but they have gone farther. They have given even more examples. So for example, somebody has given 18,000 plans. This is the paper. The papers are listed bottom. And then they show the slight improvement, slightly better improvement than we were able to see. But at some point, you start asking yourself, what is the point of this? If I'm basically giving you humongous number of additional plans, I'm just still giving you additional ability to convert a reasoning problem into a pattern recognition problem. That's all. And it's fine. So it may still be a useful thing to do in terms of just generating the next action, but it won't prove anything that it's actually able to reason about plans. Okay. In particular, actually, the extreme is we could start with untrained models. That means they haven't been pre-trained at all. There's no waste of money in terms of, OpenAI taking $20 billion and training GPT-4, and just basically train any sequence model on the same number of planners and planning examples and see if in fact there's any improvement compared to, let's say, is there any improvement for a pre-trained model compared to this tabula rasa training. And the tabula rasa training has been tried lots of times before, back before all of this stuff, back in 2016, we considered this idea that if you have word vectors, and if you think of plans as basically sentences in terms of the vocabulary of actions, you can try to kind of learn the embeddings for the actions using the same word vector model. And then we used another method to essentially predict the next word in a sequence. So you could use it for plan recognition. And in fact, it was pretty good performance. It got like nominated for a best student award, a student paper award, NAMAS, etc. at that time. A newer version of that has basically after the transformers have started in 2021, that was 16, this is 2021. People have done this idea called decision transformer. Basically, transformer is the specific sequence learning model that was being used. And it's non-trained, it's not pre-trained anymore. And you just take a huge number of action sequences and training it to predict the next token. So you are creating its own mini web, whereas pre-trained models use the existing web. Okay, and it can be, if there is in general, there are 2 points. One is, of course, you can do it this way. And secondly, there at least we know that it's not reasoning. It's just trying to learn how to predict using the patterns. What's the next action? There's no question of doing, planning by reason. Okay. So that's about the decision transformers part. That's about, as fine-tuning helping. It looks like with 15 minutes to spare before the coffee break, we have showed that LLMs can't plan, at least the way we do planning. Any of this stuff, we don't seem to be doing. Okay, so you proved it, right? It should be enough. In fact, enough people believe this actually that, people, like for example, Jan LeCun was giving a talk about LLMs in Santa Fe the other day. And then essentially, first of all, by the way, we are not the only people who think LLMs can't reason. Lots of sane people think they can't reason, but there are also sane people also seem to think they can reason. So there was actually a paper by Tenenbaum and group, which was from cognitive science perspective, trying to differentiate between language and thought. They're correlated, but they're not one and the same. And to what extent can, something that generates grammatical language might actually wind up doing reasoning behind it. And so they have some things. And then, Jan was showing that, as well as this paper that one of the oldest papers that we have written in this area, large language models still can't plan, saying, look, that shows that these things don't plan. Fine. Did that stop anybody? No. In fact, here are all the papers that are still written and well cited. Some of them are best paper awards, and there's nothing wrong with them in the sense that it's not that I don't like them or anything. These are some of the well cited papers, so I can talk about them. Okay. So their papers on least to most prompting enables complex reasoning in large language models. Chain of symbol prompting elicits planning in large language models. Chain of thought prompting elicits reasoning. Okay, that's the same thing. Language models are zero-shot planners extracting actionable knowledge. Language models are zero-shot reasoners. And there are more and more of these things. So there are lots and lots of papers. And they're published in well-refereed conferences. The refereeing is done by people like you. What can I do? Right? It depends on if you haven't heard about planning, then you think this stuff, what they're doing is probably planning, right? So why this divide? Before the 15 minutes, in this next 15 minutes, I want to give you a perspective of looking at why some people think they can do planning, and I have just shown you that they can't do planning. Have you heard about blind men and an elephant? Blind men are blind people who are looking at different parts of elephant, and they're describing them in very different ways. The elephant is a whole damn elephant, but they disagree with each other at the syntactic level. So let's go back to basics and say what planning is and what ICAPS does and what LLMs are good at. Okay, planning really contains at least two parts. One is planning knowledge. Okay, so actions, the conditions, effects, general recipes of how to do certain things in a standard fashion, like as for those of you who know HTN planning, HTN task reduction schemas, old examples of plans for sub-problems. That was like case-based planning, case libraries. This stuff is planning knowledge. And it was understood that, my PhD thesis was plan reuse, gazillion years back before you were born. And it was essentially showing that, instead of doing planning from, first principles, if you have a similar plan, sometimes it might be easier to actually modify it, and then get to the satisfying plan. And anyway, that's planning knowledge. Then the plan generation part, which is dealing with interactions between sub-goals, making sure that the plan is actually correct according to some domain model. And if you have multiple small plans for doing multiple things, how to merge them together, how to stitch them together so that there are no interactions, and how to modify a plan that you got out of the case library, making sure that the modification you're doing doesn't kill the plan. Do you understand what I'm saying? Both of these are part of planning, right? Now, if you come to ICAPS community, basically ICAPS planning assumes that the planning knowledge in some form is given upfront. That means all the planning knowledge, we basically don't focus as much on where is it coming from. There are a couple of people who talk about model generation, and they are supposed to generate the models, and we'll just use it. And in the IPC, whoever is, sucker enough to run the IPC has written the model, and then you just run your plan around that. So ICAPS assumes that the planning knowledge is given upfront and focuses on generation and verification techniques. The emphasis in our community, and it's not something that should be surprising to you, is on guaranteeing completeness and correctness of the plans with respect to the model. if it's not guaranteed, then your life will end. If you are, consider the unsound planner, if you give out a plan that actually is not executable or doesn't reach the goal state. Okay. By and large, this has become the common paradigm in ICAPS. And of course, you can do different kinds of models with more expressive models, et cetera, et cetera. That's what we wind up doing. There have been occasional mutinies, the case-based planning people basically try to say, there'll be modification techniques that have nothing to do with the underlying domain physics. That's what Chef was originally, for those of you old enough to remember. I periodically try to push this idea of how to do planning when the model is not guaranteed to be complete. In the sense, we know that the model is incomplete and you still want to do something with of planning. And I used to call this model-like planning. But mostly we don't ignore all that stuff. We just assume the model is correct and just show the plan is correct with respect to it. If we were actually supposed to generate the knowledge, and if you're asked where is the knowledge coming from, you have no idea. You just hope that the model maker somehow got that knowledge. And and before I go to the next part the LLMs do, let me make you remember that. How many of you seen this show called MacGyver? Okay, MacGyver essentially is able to solve surprisingly planning. He gets stuck in something and there is no domain model that Chris Musi or somebody has written for him. He has to take the entire world of all the possible contraptions he has and try to use them in uncommon ways to get out of the mess. This is what we humans do. When we say crows are intelligent, we see that they're able to make tools and use the tools in solving the planning problems. And then humans is the same case. ICAPS community doesn't particularly care about where that knowledge is coming from. And let's assume that. And let's just kind of agree with that, okay, to some extent. If there are people working on that, but we don't take it as seriously. And if you go out of this room, people are impressed if you're just coming up with a good action, that you are supposed to do at a particular time. They don't care about the fact that you don't know how to deal with interaction resolution. You thought of the right action. People are impressed with that. Let's just, realize that. LLMs, trained as they are on everything that has ever been put on the web, have a kind of approximate omniscience. And you really don't have an idea of how much stuff is there on the web. And so what this helps them is to spit out actions, recipes, cases when asked. They're not guaranteed to be correct. They're not guaranteed to make sense, but they actually in the right format and they look reasonably, often right. And if you look at them, you'll say, when I said, can I do a Prague plan? How do I spend time in Prague? It comes up with a plan. And the reason I'm impressed is not because it knew my constraints and it made sure that scheduling is right. I'm impressed because it knew Prague. If I ask some random grad student who will say, what is Prague? I have no idea. What do I know how you're supposed to do it? Give me a PDL domain model, then I'll tell you what the plan is about what you're going to do. So what we consider planning typically is just knowing the planning knowledge. Do you guys understand that? So when we come back, actually, one of the things that I'll point out to you is a lot of papers that are actually using LLMs and saying they're doing planning. They really are using LLMs to generate approximate task reduction schemas or approximate plans and hoping that they're good enough for people. And the people in the loop, they look at it, yeah, this looks like a good wedding plan. How many bad wedding plans can you come up with? Seriously. There's a reasonable number of standardized wedding plans. And, if you ask me if I've read enough, brides and grooms magazines, I can give it to you. I have no idea what your constraints are, but I can give it to you. You understand what I'm saying? And if I needed that information, I'm impressed. I don't care about the fact that you don't know that the plan is not correct. And in fact, so LLMs trained as they are in the whole web basically have this omniscience, approximate omniscience, but they lack the ability to stitch the recipes together to ensure that they are actually interaction free and that they will be executable. The stuff planning people as well as RL people care a lot more about. Okay, so here's a way of thinking about it. This is something with respect to what I said earlier. AI planners will give formal guarantees, but will only give it if you have given them domain model in the format that they expect. Otherwise, they'll say, move on, move on, move on. And LLMs accept anything, not just planning problem, but they certainly accept any planning problem, whether it's wedding planning or block stacking problem or something else. And sometimes they're right, sometimes they are wrong. And especially when there are interaction resolutions, they are wrong most of the time. That's what I've actually shown you up until now. Okay. So this sort of makes you think about, since we are a community which are into relaxed domain models, and we know that interactions come from preconditions and delete list interactions. What if I took the same domain models? Remember, I'm into giving as much of the benefit of doubt as possible to LLMs. I took the same IPC domain models, relaxed them. So delete relaxation, precondition relaxation, both together. And see if, in fact, will they ever say the right thing? It reminded me of a joke where the teacher is asking this, it makes sense only if you understand the stupidity of English language as to how, it's not phonetic at all. So anyway, the teacher asks the student, please spell the word coffee. I'll give you partial credit, even if you get one letter correct. And then the student comes up with K-O-U-G-H-I, which actually can be pronounced as coffee in English. You see what I'm saying? So my question was, I was giving as much of help as possible. I'm relaxing the deletes, I'm relaxing the preconditions, I'm relaxing both also. Will your performance improve? Certainly you see its performance. The green stuff has increased now. And yet there is still red stuff. First of all, we are realizing that we are no longer in the real world because we are relaxing all these interactions. And secondly, we are also realizing that even after you remove deletes and preconditions, at the minimum, the LLM should know how to make sure that there is something supporting every possible top-level goal. It doesn't even do that. Oftentimes it fails because it doesn't actually have somebody supporting one of the goals I asked it to do. You see what I'm saying? So that's another study that sort of tells you, but both that they're doing interaction, and secondly, even with the interaction removed, they're still, better, but not, perfect. So the very last slide before you get the coffee, and we'll come back and continue, is how come LLMs are trumpeted as doing planning if this is all true in some communities? So as should be clear by now, because I've already foreshadowed it, in most cases where LLMs are claimed to generate plans, on closer examination turn out to be cases where LLMs are getting by with the generate approximate recipes step. And they do that by essentially using their completion facilities. So you can do wedding plans, or a Prague travel plan, etc. Sometimes they can convert tasks into approximate task reduction schemas. There is this one particular paper that has gotten a humongous amount of buzz called Code as Policies. So it asks, pick up something, and then LLM generates like a piece of code. Wow, it's like, almost unicorn all over again, a piece of code that corresponds to actually solving that particular one single task. But that doesn't require you to understand interactions at all. It just requires you to remember what is the way to do this task, standard way to do this task. And if you've read enough literature, you have known that. If you read enough web, you'd know that, okay? So there's a convert tasks into approximate task reduction schemas, perhaps written out as programs, and that is like the paper Code as Policies that I'll show you in a minute. Remember SHARP2 schemas? How many of you remember SHARP2 here? Okay, Pascal Bercher is somewhere else, I guess. But SHARP2 is this HTN planner. Dana was the LLM that wrote those schemas. He wrote the programs. SHARP, actually, one of the things that people used to complain at one time was SHARP basically removes the sacrosanct distinction between domain physics and domain control, because he not only writes the program, but he also actually tells how to sequence them. LLMs can't do the sequencing part. They can at least write the program in terms of which pieces should be done as what piece of code. Okay, that is something that they wind up doing. So in fact, one thing that we'll look at when we come back is you can think of stuff that we used to do that we don't do anymore, such as HTM and CBR, case-based reasoning. You can do LLM HTM and LLM CBR, because CBR fell by the wayside because who is giving you these code libraries? LLM will give you the case that you can modify. Okay. Similarly, HTM, the question is, if it's hard enough to write PDL domains, who is giving you the domain task reduction schemas? Pascal says they're all over the place, but who is actually writing this? LLMs will give you bad reduction schemas that people in the loop can then improve them to generate a better model. That is something that's a useful thing, and I'll show you how to do that. Okay. And the interaction and resolution and search part is either pushed under the rug. That means Consider high-level plans like wedding plans. You don't know that just because that plan actually can be written down means that it can actually be executed. There are all sorts of interactions that have to be handled in concretizing the plan. At a high level, everything is doable. If you believe that you can, and even those of you who are about to get married and you say, oh, somebody say, have you made all the plans? And, oh, yeah, I already asked ChatGPT, it gave me the wedding plan. You're screwed, man, or woman. Because actually on the day comes, then essentially there'll be all sorts of resource constraints and your wedding won't happen. Okay? Because it's at a high level, everything is doable. But part of planning is making sure that it is actually doable in the execution level. Okay? R has been part of to human prompters who are required to give hints to the LLM to come with the plan variants that are more correct. This is the whole clever hand stuff that I was talking about. If you haven't thought about it this way, you could read these papers and say, this is in NeurIPS, it's doing planning. Why am I still coming to ICAPS? Do you see what I'm saying? So it's worth understanding that there are ways in which you can push things under the rug, and people don't necessarily. One of the most important things about clever hands is the owner was not deliberately trying to cheat. He didn't know that the stupid horse was sensing his stress level. He didn't even know that there's such thing as stress levels that can be sensed. He found that it was doing it, so he started putting it on the exhibition. He took it from place to place. People were giving him money. At some point of time, people said, look, man, this doesn't actually say that it's doing mathematics. So that could actually be happening here. The people writing these papers don't necessarily think that they're cheating. They basically are seeing this, but they're essentially giving enough hints that will come to the correct answer. You put this skeptical outlook on your skeptical classes, then these papers will start making very different sense to you. Okay. So again, when you're doing this, human is essentially doing the role of the external verifier and critique. You can do generate test if there is a tester who knows what the correct answer is and gives useful feedback. So in fact, these are some of the well-known recent papers called React, Inner Monologue, and Tree of Thoughts, which all try to do this chain of thought style planning and claim that planning improves quite significantly. And also one of the other things is they use problems for planning, just as you don't even think of wedding planning as a planning problem because you are too corrupted by ICAPS and think Block's world is the only planning problem. That's the kind of thing. Many outside people think everything is connected to planning. So for example, the game of 24 is the one that this last one, Tree of Thoughts paper is using as one of the examples, if you can see here. And the game of 24 is finding 4 numbers that add up to 24. 4 positive numbers that add up to 24. Okay, we consider that as a planning problem. One interesting thing is, A, you would say, why is it a planning problem? And B, you will say, I can't write it in PDF, so it's not a planning problem. But if your customer thinks it's a planning problem, it's a planning problem. And this is where the fact that LLM will consider both Block's world plans, it never yelled at me when I asked it to solve Sussman anomaly. With the same level of bravado, false bravado, it answered that. It also, with the same level of false bravado, answers this game of 24 problems, where actually it comes out with the wrong answers. People will give useful feedback, and then it tries to come up with the right answer. That is how LLMs are nudged into doing planning. And you have to ask yourself, when is that a reasonable thing to do, when it's not a useful thing to do. One last thing, the Inner Monologue paper actually has Block's world examples, which is very surprising because nobody else considers Block's world as the planning because that's considered out of scope. So these guys, so I was very excited. They say, we do the N stack problem, the 3 stack problem. I said, wow, okay, 3 stacking requires, interaction resolution. So I looked at it and they have good numbers. Then I made the mistake and looked at the appendix. And then it points out that the 3 stack problems are all done in such a way that the 2 of the blocks are in the correct configuration and the third one has to be put on top. That's a 3 stack problem. So if you are thinking that is a stacking problem, then I have a 10,000 stacking problem where 9,900 blocks are put in the correct configuration. You just have to put the last one on the top. Do you understand what I'm saying? Again, I don't think they're cheating. It's just people don't understand. All of these are considered planning. You are a lot more predisposed to think that certain kinds of problems are considered planning and not others. And in terms of what is planning, both of you are right. As I said, essentially, it's like blind money and anything. And then we can ask ourselves, since both are required for planning, how can we benefit from LLMs? Which is what we'll do if you decide to come back after coffee. Thank you for your patience for the first half.